All right, welcome to Module 1, which is Proportional Relationships. You can see here all the different things that we're going to learn. So this is Lesson 1, 2, 3, 4, 5, and 6 listed here, and the standards on the right. So what you're going to learn, overall, we're going to be computing unit rates involving ratios, determining whether a relationship is proportional, and doing the same thing while looking at a graph. We're going to learn about how to identify and understand what a constant of proportionality is, and then interpreting these particular coordinate points on a graph. Okay, and then we'll represent proportional relationships with equations and solve some other word problems with proportional relationships. So those are some things that we're going to be working on. You have some experience from 6th grade with these, and so you'll see some things are a review, but some things are going to be new for you as well. Vocabulary-wise, you've already heard of unit rate before. I believe you've talked about proportions and maybe proportional relationships, and something being non-proportional. But constant proportionality will probably be a new one for you for 7th grade. This is just a quick review to remind you some things about ratios, because that's important. So I'll start off in red here. A reminder that when we're looking at ratios, order matters. Okay, so that's something you're going to hear me say a lot when we're working with ratios of any type. And so you can see the ratio of wins to losses is 10 to 12. And you can see it's stated there as well. And they're asking you, what's the ratio of wins to total games? And so all I want to do is look at that order. And so the ratio of wins has to be first, and that's 10. And then I'm going to put my colon and put total games, which if you add up the wins, losses, and ties, you can see we have 30 total. Okay, so I'm going to go ahead and write these here. You'll notice that you can write a ratio like that. You can write a ratio as a fraction. You can also write a ratio in words by saying 10 to 30. Okay. All right. Now over here, they're showing you some examples of how to determine if ratios are equivalent. Okay. And you've created equivalent fractions in 6th grade. So let's take a look at that. Number 2, it says determine whether the ratio's 20 nails. So I'm going to grab a highlighter here. For every 5 shingles, and 12 nails for every 3 shingles are equivalent. Okay? And so I want to set those up, and remember, order matters. We've already said that. So 20 nails, I'll just use an N for nails, and 5 shingles. So you'll see we also want to put labels when we're working with different rates, or any ratio really is good to be labeling things to keep your stuff organized. And we're wondering if they're equivalent, so I'm actually going to create a proportion and see if they are equivalent to each other. So I need to make sure the 12 nails are on top and my shingles are on the bottom. Okay. So one way that you may remember in the past is to do the means extremes, which is also called cross multiplying, and we'll get into those things later. But another quick easy one is just to divide the numerator and denominator. And so let's go ahead and do that. So 20 divided by 5 is 4, and 12 divided by 3, because fraction just means division, right, is also 4. And so we can see the proof that these are equivalent, okay, or their unit rate is 4 nails for every 1 shingle, okay. And so that's just a little bit of a review. Let's go ahead down into our actual lesson today. So follow along, fill out everything exactly the way I do, so that you have accurate notes to study from later. So our I can statement today is I can find unit rates when one or both quantities are fractions. Because really, ratios are just fractions. They're a type of fraction. And it's a lot easier to do math work when they're written as fractions than if they're written with the colon. So let's go ahead and focus on some unit rates today. It says, what is the ratio of boys to girls in our class? So I'll just go ahead and give you a number of 8 boys and 15 girls. I want you to remember that there are 3 ways to write a ratio. So let's go ahead and list those here. So we can do it by writing 8 to 15 with a colon, 8 to 15 with words, or 8 over 15 as a fraction. Okay. I do want to spotlight here the difference between ratio and rate because you're going to hear me saying both those and you're also going to see them. The biggest thing is that when you are using the word per, okay, like miles per gallon, or calculating a better deal with price per ounce and things like that, those are rates because they compare completely different units. Okay, so miles per gallon are completely different, whereas a ratio, okay, all rates are ratios too. Okay, but a ratio is going to be similar units. Okay, so boys to girls, things like that. And I know you're saying, well, boys and girls are different, but they're still similar units. We're comparing human beings versus miles and gallons, which are two different things. Okay, but using those keywords are the big way to tell the difference. All right, so there's two typical ways to write a rate. Okay, so we just talked about ratios. So now let's talk about what rates could look like. So a rate can be written in words, and you can see the average price of the gas in Pennsylvania is right here. And so we can say in words, $4.51, and we can write the word per gallon. Okay. As a fraction, if we look at New Jersey now, okay, we can say $4.47 over 1 GAL. Okay, so those are the two different ways we can write a rate. Okay. All right, so let's go ahead and take a look at how rates compare two different units. So I want you to see, when we're talking about unit rates, the thing to remember is unit rates are always over 1 unit. Okay, and so that could be over 1 gallon, 1 ounce, things like that. But it just has to be over 1. Unit cost is the same idea, but it's going to be dealing with money. Okay, so we might, when we're talking about unit rates with cost, you just need to make sure that the money is on top. So that would be something like $5 per 1, and maybe it's a gallon, an ounce, or something like that. Okay. So any of those things, a price per ticket, a price per gallon, price per ounce, those are unit costs. Either way, just remember that unit means over 1. Okay. All right, so let's fill this in. How to find unit rates. Okay. It is nice and simple. It's going to be the same every time. You just take the numerator and go ahead and write that division symbol. Numerator divided by the denominator. Okay. Put the answer over 1 and make sure you label. Let's go ahead and practice that so you can see what I mean. So Tia is painting one side of her shed. She paints 36 square feet. So I want to highlight that important info in 45 minutes. That's my ratio. Okay. Or we would specifically say rate because it's two different entire units. Okay. So it says at this rate, how many can she paint per hour? Okay. So one thing to notice is they're asking per hour, but this is written in minutes. But they are letting us know that 45 minutes is 3/4 of an hour. So I'm just going to, my tip to you would be get rid of that and just call it as it is and say 3/4 hour. Okay. If I really want to simplify things, we also know that this is just 0.75 of an hour. And I don't even have to deal with the fraction is an option. So remember we said order matters. So let's go ahead and set this up on the side. So we said 36 feet squared per 0.75 hours. Okay. And let's look again. How do we find unit rates? Numerator divided by denominator. Okay. So write equals, put it over 1 HR, 1 hour. Numerator divided by the denominator. That's what the fraction bar means. And the answer goes up top. Okay, over 1. So let's grab our calculator. I'm going to use our Desmos here. 36 divided by 0.75 is 48. So slide that away, and we have 48 feet squared per hour, and that's our unit rate, and everything's labeled. Okay, and then use reasonableness. If she can do 36 feet in a little under an hour, does it make sense that she can do 48 feet in an hour? Yeah, it does. Okay, so that's all you have to do. That's how to find unit rates. So let's try it again with this. Okay, here's our info, and here's our rate of 5-6 miles. That's not the tool I wanted to use. 5-6 miles in 15 minutes. Remember, order matters. Okay, so let's write our original ratio of 5-6 miles per 15 minutes. But look, it's asking per hour, so let's get rid of the 15 minutes, and they're giving us information here that this is just 1/4 of an hour. But let's go ahead and just put 0.25, okay? Because that's really what 1/4 of an hour is, okay? However, we have a fraction up above, and let's look and see. If that fraction can't be turned into a decimal anyway, 5 divided by 6, look, we get a repeating decimal. So really, it's going to be in our best interest to actually use the fractions. Okay, so I wanted you to sort of see what my thinking is sometimes. Okay, to go, oh, decimals are nice, but sometimes they're actually not if we're dealing with repeating decimals. We have to use a fraction. So 5-6 miles over 1/4 hour. And don't get too freaked out about this. This is a complex fraction when you have a fraction over a fraction. Okay, and that's completely fine. It functions the same way as any other whole number. Okay, so let's go ahead and set this up. We want to find the unit rate, which means over 1, to figure out how many miles per hour instead. Okay, so how do we find unit rates? Try to remember. Numerator divided by denominator, answer over 1. Okay, so 5-6 divided by 1/4. Now you do have to remember from your prior math learning, you cannot divide fractions. Instead, we multiply by the reciprocal. So let's go ahead on the side, and we'll set up 5-6 times, and reciprocal just means flip the fraction, 4 over 1. Okay, and we'll see what that answer is going to be. Now, I always see if I can cross simplify, and I can here. We can divide both those by 2, and we get 2 here and 3 here. We don't need a common denominator with multiplying by fractions, so we multiply straight across, and we get 5 times 2 is 10, and 3 times 1 is 3. So that's 10/3 miles per hour. It doesn't say it has to be a mixed number, but we could also, if we wanted, we could put, let's count by 3s, 3, 6, 9. We could do 3 wholes and 1/3 mile per hour. Okay, both those would be acceptable for that unit rate. Okay. All right, here's our last one in our notes today with practicing unit rates. It says Carolina and her friends are training separately for kayaking competition. The average distance and time traveled is shown in the table. If the distance is 3 miles, predict who will win based on the rates shown. Predict how long it'll take the winner to complete the race if their rate remains constant. Okay. All right, so let's go ahead and find the average distance and average time, but as a unit rate, so we can do some calculations. Okay, so we want to find the unit rate for each of these people. When you have a table like this and it doesn't tell you the order, you have to do what makes sense. Okay, so would you do miles per hour, or would you do how many hours per mile? Okay, and so that's your thing you're going to have to think about a little bit here. We are going to want to know for 3 miles. And so in a way, I sort of want to know how fast per mile, so that then I could just multiply that to see what 2 and 3 is. Okay. And so one thing that you'll sometimes run into is sometimes, even though miles is on top, you're going to need to flip-flop these for it to make sense. Okay, and so really, I'm going to do it like this, and we're going to say 1/2, okay, and this is time, hours per 7/8 miles, okay, and so to find our unit rate, okay, remember that we divide the numerator by the denominator. I'm going to do it underneath because of space. And write that over 1 mile. So we're coming up with the unit rate for each person, okay? So let's go ahead and do our division, but remember, we don't divide fractions. So on the side, I have 1/2 multiplied by the reciprocal, which is 8/7. Look and see if I can cross simplify, and I can. Divide by 2 is 1, and 2, 4, 6, 8, that's 4. And so we have 4/7, and that's hours per mile, okay? So let's check the next person. Oh, look how nice this is. 1/3 hours per 1 mile. It's already set up as a unit rate. We don't even have to do anything that way. So that sort of works out nice. All right, and then this one, look how nice this is. 3/4 hours per 3/4 miles. Well, 3/4 divided by 3/4 is 1. So that's actually going to end up being 1 hour per 1 mile, okay? Because it's a 1-to-1 ratio. And then our last one, let's go ahead and set up 2/3 hours per 1 mile. It's already in a unit rate, so we're done with that one too, okay? So the question is now, who will win, okay? And so we want to know who can do a mile in the shortest amount of time, okay? So if you look at all these numbers, okay, some of them have different denominators, so you have to be a little bit careful. But we can look at some things like this, okay? So I know that 1/3 is less than 1/2, okay? So I already know that this is more than 1/2 because 4 is more than 3.5, okay? So this person beats out this person here, okay? So this is not it. And let's look at some more here. This is more than, this is an hour for a mile, so that's more. And this is 2/3 hours per mile, which is more. So we can see that the person who does it in the shortest amount of time ends up being Leslie. So I'll make her stand out. Okay, so she wins the race, but it does say predict how long it'll take her to complete the race. So sometimes what I do is I'll make a little note and say, okay, predict who wins and how long will it take her to complete it. So a lot of these applies, they have 2 steps. So if we know that she's doing a mile in 1/3 hour, since that's the unit rate, to do 3 miles, we can easily multiply that by 3 to see what it would be. But if we were to write it as a proportion, here's how it would look. 1/3 hour per 1 mile. And so the question is, what about for 3 miles? So we can just look and see, well, the multiplier is times 3 over 3 because they're equivalent fractions. And so 3 of the 1/3 is 3/3 or 1 hour, okay, per 3 miles. And so there's our information for part number 2. All right, so those are your notes for lesson 1. When you head to your homework, you'll notice that the homework will say, hey, this homework problem is just like example 1, so you can put these side by side to compare and help you out with that. Okay, all right, good luck, and let me know if you have any questions.